My name is Emmanuel, and I work for Wolfram Visualization team. And my talk will be about geographic visualization. So I'm essentially going to show off new functions for visualization of geographical data. And then we are going to compare how different data can be visualized in different ways by using the functions for geographic visualization. My name is Emmanuel Garces, and I work for the Wolfram Visualization team. And today I'm going to talk about, we call it Geo for short, yeah, right? But it's geographic visualization functions. So the overview of the talk is to give a very brief introduction to geographics as a function. Then I will introduce a new function in version 11.3 called Geo Smooth Histogram. Then after introducing this function, I'm going to compare how same data can be visualized by using different visualization functions that we already have. After that, I'm going to focus on particular features of those visualization functions. And the last thing I'm going to talk about is new functions that are going to be in version 12. Okay, so as probably many of you know, we have a Geographics function that allows us to show maps. We can feed that function with cities, countries, or any other place in the world by giving some ranges. So there is no limit for specifying what map we want to show. Geographics have different options. One of them is U-scale bar. As you can see, there is a little bar here showing us the say the distance or the proportion of the map according to miles or kilometers. We can show geo grid lines according to angles or probably distances. Geo range, in this example, we are showing just 1 point, but the geo range given in this example is a country. In this case, is USA. We can feed geographics with geo backgrounds. We have different settings for geo background. I'm just showing 4 of them here. We can change the geo projection. In this case, I am only showing 4, but we have many of them. There are different kinds of geo projections, right? So we also have primitives. There are several of them. I am only showing 4. We can highlight a polygon. We can put geomarkers in the map. We can put geocircles by setting what is the radius of the circle we want to show. We have things like showing what is the part of the world with night or day. We have some others, but I'm only showing some of them in order to let you know what can be done with geographics, right? So we have like 5 or 4 functions that allow us to show data into that map. The new one in version 11.3 is called Geo Smooth Histogram. Probably many of you have heard about GeoHistogram. That is a discrete version of this new function. The old one shows us we have a set of points and we want to know how many of them are falling into some bins. In this case, the default bin shape is a hexagon. So in this example, we have the cities of Ireland, right? So in this case, in this area, we have just 4. So this is a histogram for maps. We have points in the maps, and we show the histogram. But we also can plot. We can use histogram for showing regions with positions associated with values. In this example, we have the largest cities of USA associated with their population. For instance, in this area, we have this number of populations, right? Of course, this is near New York, and this is Los Angeles, and so on. No? So here we are showing how many people we have there. So we have 2 different ways of use GeoHistogram. But now, with the same data, we are using the new function GeoSmoothHistogram, and this allows us to see the same distribution, but in a smoother version. So we are here we are using a plot of the PDF based on the smooth kernel estimate from the same data. So this is the same example we saw before for the cities in Iceland. And this is the same example for the population of the larger cities of the USA, but using this new function, right? Okay. As we are using a smooth kernel estimate, we have parameters for this. So one of them is the bandwidth. In this example, I'm just showing 2 of them, but there are more methods. So I'm showing those 2 because those are looks really different, right? So as you know, the bandwidth determines like the area covered by the intensity plot. Another parameter for this PDF is the kernel method. We also have several of them, but I'm just showing 2 of them because they look different. So you can try with different methods. By the way, this is the symbolic interpretation for geopositions. So you can use different kind of inputs, but in this case, I'm just using this object as input data. Okay. There are many options for GeoSmooth histogram. You can you can mix different options coming from Geographics and also coming from smooth density histogram. So as you can see, the 4 examples at the top are options for Geographics, and the 4 options below are coming from smooth density histogram. So you can mix both options and see interesting results. Okay. And as application example, we have in this data the positions of registered trees here in Champaign, and then we are showing here a GeoSmooth histogram of those positions. So as you can see, this is a map of Champaign. You can see the red areas are almost the same, right? As a matter of fact, when I was flying from, I come from Mexico. So when I was flying near Champagne, I saw a very similar distribution of the trees. So it's interesting, this example. Okay, this is the new function for 11.3. Now that we have that function, we can compare different functions by using the same data. So in this case, the data is the position of the European countries. If we use GeoListPlot, we get this image that it's not that interesting because GeoListPlot only shows the regions where the points are located. If we use GeoHistogram with the same data, as you can see, then we are showing the number of countries that are inside in every bin. So, for instance, in this bin live 3 countries, right? But if we use the new function GeoHistogram, we get a similar distribution, but in a smoother version. Okay. What happens if I use an array of coordinates? As this is called an array of coordinates. And we use the same philosophy that we use in the example before. We have a random set of points. Now I'm using random geoposition. As you remember, yesterday Stephen introduced this new function that allows to generates a homogeneous set of points for a given area, right? In this case, we are giving as a data 300 random points of the world, and the same thing happened. If you use GeoListPlot, we are just showing the points. If you use GeoHistogram, we are showing the points in every bin. In this case, well, you know, this is homogeneous, but there's only 300. Maybe if we use, I don't know, 10,000, that will look like that. But if we now use histogram, we get the smoother version of this one. So this is the discrete version, and this is the continuous version, let's say. Okay. Another example of same data shown by different functions is geoentities associated with some values. Now, those values can be numeric or can be quantities. In this example, I'm showing the, okay, we have the population of the Americas countries. So if we use region value plot, we are showing with colors the quantity of the number of population of each country. So as you can see, USA and Brazil have more population, and so on, according to these colors. But now we can use GeoBubble chart, because GeoBubble chart also uses relations between positions and values. But in this case, GeoBubble chart uses bubbles, and their sizes are proportional to the quantities or the values. We can use also GeoHistogram because GeoHistogram can also be fed with positions and values. So in this case, the USA, in this area, we have this number of populations and so on. But we can use smooth histogram. As you can see, there are many people in this area, right? In this point. Okay, so it's the same data, but we are using different visualization functions. Now, another example is entities associated to quantities. In this example, we have some counties for some US states, and the value is the per capita income of each county. So we also use GVectorPlot. We can use GVectorPlot, but this is not very interesting because almost each county has the same income. But the interesting thing here is that as we have many counties here, so the income is more in this part of the country, right? And it looks like the same as just smooth histogram. Okay. Well, we can use associated map that also shows the same. In this case, is the population of the European countries. Okay, let's continue. Some particular features of visualization functions is that GeoListPlot can plot set of groups of entities. So for instance, if we group those, then we have different colors, right? That's a property of GeoListPlot. GeoHistogram also supports different bins, not only hexagons. It supports rectangles, triangles. In this case, we have, it depends of the area, right? We have 1,000 acres, or we can define, for example, a school district. In this case, here we have one entity, I mean, what point in this school district entity, and so on, right? Bubble chart has the ability to show bubbles according to their data. For instance, this is the map of the area of each state of the USA, and the blue area is showing us the farmland area of each one. So we are using pie charts instead of bubbles. The new functions for version 12 are GeoVectorPlot and GeoStreamPlot. GeoVectorPlot essentially takes as input a GeoVector object. Tomorrow, Jose at 2 p.m. in this same room is going to talk about the structure of GeoVector. But as you can see, we can plot vectors, a vector field, streamlines coming from that vector field. So the input is the same. Okay. These two new functions accepts also an object called GeoVectorENU. Okay, let me explain quickly. GeoVector itself is a set of vectors, and each one of them contains a modulus of the vector and a bearing, I mean, a direction, right? But we can also define a vector not just as a modulus and a direction, but we can define a vector as a north and east component, even an up component. That's where the U stands for. That's east, north, up. But in this case, where you're just using east and north, but of course in the future, for example, for magnetic vectors, we can use the up direction. Okay, we can also use quantity array, as you can see. There are different combinations of inputs, but I am only showing few of them because there is not really big time for that. Now, options. In this case, as GVectorPlot is using, let's say, it's almost the same like list vector plot and Geographics. Then we can mix options from Geographics and list vector plot. So as you can see, we can use GeoBackground, for instance. We can use GeoVector scale, vector color function, and so on, right? Remember that vector markers, as if any of you attended Brett's talk, he told us about this vector markers option. So in this case, I'm using the Dart vector, right? So let's see the options for streamplot. I'm in GeoStreamPlot. It's almost the same case for GeoVectorPlot. You can use options from listStreamPlot and Geographics. But in this case, for instance, we don't have vector style. We have stream style. We have stream color function. We have stream color function scaling, and so on. So we also have stream markers. In this case, I'm using a different stream markers. Okay. Now, what can we do with this, right? As an application, I remember when the Hurricane Florence, I collected some data from our own databases, wind data, and then I collected that information, and I was able to produce this plot. Okay, so that's one application for GVectorPlot. As you can see, I didn't talk about this option. This is showing us only the part of the vectors for the US area. So we are not showing vectors at the ocean, right? So we can really limit the region where we can show the vectors. Another application for streamplot, I'm using geomagnetic model data. So this is the streamlines of the, as I said, the geomagnetic vectors at the North Pole. So it's really interesting how, as you can see, every stream is pointing to the magnetic North Pole, right? And there are 5 seconds left, so I finish time. Okay, thank you very much.